m is thrown straight up with velocity v0. Find the velocity v dash with which the body comes down if there is a drag force kx square, where k is constant and v is the velocity of the body. So if we consider the upward motion of this object, when it is moving upwards, there will be two forces acting on it. Definitely gravity will be acting in downward direction, as well as the drag force, which will be proportional to v square, is also acting in downward direction. If we assume there is some velocity v in upward direction here, that velocity will be a decreasing quantity and ultimately it will reach 0. So if I write the force equation here for upward motion, we will be getting mg plus kv square will be is equals to minus of m into dv by dt. Here I am indicating the negative sign as the velocity is a decreasing quantity here. So from here I can just separate the variables here. Instead of writing it as dv by dt, I can also write it as v into dv by dx or dv by dy. As it is in y direction, I am going for dy. So the same equation can be rearranged into different variables as v into dv divided by, you can cancel out here denominator, you can write it as g plus k by m into v square, and on the other side I am going with the y variable dy minus sign. I am adding it to the left hand side. Then when I integrate it for the complete upward motion, let h be the maximum height up to which the particle is going to move. Initially it started with a velocity v0 and ultimately its velocity is going to be 0 at its zenith or topmost point. Here we can solve this integration by taking this substitution. Let the denominator g plus k by m into v square is equal to some z. So on differentiating we will be getting v into dv can be written as m by 2k into dz. Right. Let us substitute this z value and v into dv value in this integral. On substituting we will be getting m by 2k integral v0 to 0 dz by z will be is equals to, the left side integral remains as it is, 0 to h dy. Right. So this m by 2k I am going to take it to this side, and this left hand side is simply is going to be equals to minus 2k by m. Integral 0 to h will become h, and this will be simple logarithmic integration. So ln z, when we integrate it from v0 to v, on reverse substituting it back, we will be getting here ln g plus k by m into v square. I am just reverse substituting in the value of z, and here the limits are from v0 to 0 is equals to minus 2k by m into h. You can just substitute the limits and check what is happening. Here I am just writing the final value, which is h is equals to m by 2k into ln 1 plus k by m g into v0 square. This is the maximum height. This can be a question where they can ask what is the maximum height up to which the particle is reaching. Now when we consider its downward motion, in downward motion now mg is definitely is going to act in downward direction, and drag force will act opposite to its velocity. So I have to take here kv square upwards. So as here we can generally think that due to the gravity it will be accelerating and its velocity is increasing. So I can write the force equation for this downward motion as mg minus kv square will be is equals to m into dv by dt, and again instead of this dv by dt I can just write it as v into dv by dy. Right. So again separating the variables, we will get the integration. Similar one, just the signs will change here. G minus k by m into v square into is equals to dy. Again going for a similar integration, you can go for the substitution and you can just check this. So here the initial velocity was 0, final velocity is v dash. Here initially it is 0, finally it is going to be h in downward direction. So after doing the calculation, same substitution, you can just take this as z and substitute it here. I'm not going for the integration part. You will be getting something like g plus k by m into v naught square divided by g is equals to g by g minus k v naught v dash square divided by m. Just rearrange it and try to make this v dash as the subject, and I'm just going for the final option, which is v dash is equals to v naught upon root of 1 plus k v naught square divided by mg. Alright, so if we go and check the options, it will be matching with the first option given in the question. Thank you.